So here's, I'll start off with our learning targets, and by the end of this, you'll be able to describe what conventional parts make up an atom, and be able to describe the number of protons, neutrons, and electrons that are found in an atom, and you'll be able to describe the difference between an ion and a neutral, that's in the way, I'm sorry, a neutral atom. So maybe, can somebody actually, because I'm trying to work on my public speaking, can somebody keep track of like how many times, thanks. Can somebody keep track of how many times we say so or like all that stuff? Thank you. Crunch words, watch out for them. Okay, so there's two of them right there. Let's go with elements. So there are more than 100 elements that have already been discovered or created. This lesson is going to focus on the first 18, which are composing most of the matter in the universe. The lightest elements are hydrogen and helium, and hydrogen is also thought to be the first element that appeared on Earth. So this is a little bit of a backstory to what you already know, but I thought I'd give everybody a little refresher before we get started. Currently, more than 20 elements are not derived naturally, but many have been synthesized by humans. So elements can be categorized by many ways: name, symbol, atomic number, atomic mass, boiling point, and melting point. So just to remind you the difference between elements and atoms, you're going to be confused about that. This is the normal convention for how you can logistically work out what an atom is. It doesn't look like that in nature, but that's how we will use it to describe it. Atoms, if you take apart anything, it can just get smaller and smaller, right? So like our limits of detection, we label something an atom, and then when we become more proficient, we find that there are smaller things in them, so then we name those. And so we'll call them subatomic particles. Sub means smaller than, and that's what these particles are. This is a little bit more accurate. Sometimes you'll see atoms described as orbitals around Earth-like structure, so that would be your nucleus in the middle. And what's more accurate is this idea where the electrons are so small and moving around so fast that we can't determine where exactly it is. So we draw it as a cloud, we draw it as a shell, we draw it like this, but in actuality, these would be the probable locations of an electron. And we can go into that much later. But at your tables, there are these little group cards, so I'll give you a minute to decide who wants to be what. And there's 2 people too many at this table. So if you mind, maybe one person going over there, and one of you guys can go over and help them. I think we might need our workbench. That one. So you're not in this alone. Just in case you thought the learning targets were a little bit
Hey guys.
advanced.
Hello.
Yes?
We have
Are
an extra one.
Index cards also something we need?
Write that.
Yeah, so like,
Should I put this over there?
okay, I'll go get it back. So go ahead and pick up the roll.
There's yours. There's 3. There's only 3. They want me to do something else.
I'm a cheerleader.
No, it's fine.
I'm the manager. Let's do it.
Oh, that sounds about right. Quality control.
Quality control?
Yeah.
Time. I'm so not good at time. This is going to be challenging for me.
Okay.
Mine to help her with the time thing.
Normally familiar with these because we've been doing a lot of group work, but I'm just giving you guys a minute right now to look over them because you guys have never done this before.
Really? The person with ADHD picked that one up.
Are you a cheerleader?
All right, so
Oh, you're the cheerleader.
I'm the spokesperson, so I'm the one to report
Encourage.
to the teacher.
In general, yes. There's somebody who
Tell.
keeps track of the
Perfect.
time, somebody who reads the information, somebody who makes sure that everybody's in agreement, and somebody that is the, obviously,
Okay.
So everything you have to answer your questions is in front of you. So between these 2 models, So I gave you this model in your packet. This is what you'll use to answer the questions as well as the periodic table. So I'm gonna go around and make sure everybody understands what their job is.
So we're working all together.
And make sure everybody has a packet.
Okay.
Okay, so it looks like we have questions to answer, and this is, we reference these 2 pages to find the answers. So the first question is how many protons are found in
You're on top of it.
12C, 13C, and 13C negative. I assume that's how you pronounce that, but I'm not 100% certain that's accurate. But it looks like the one with the bigger squares on it is probably where we're going to find that information.
I agree. Well done.
So,
As far as I can tell, it's, okay, 6.
all right, so then we have the C12C, which looks like it's just regular old carbon 12. Yay! Okay, so then the question was protons. Does anybody
You
want
have
to?
5
I
minutes.
see 6 protons
So
in
just
each
give
of
your
those
table of
6
wording in
protons.
5 minutes.
I did as well. Anybody see something different?
So 6, right?
Sweet. I believe that 6 looks
I'm-
like the right answer.
Does it mean all together or individually?
I think it's together.
It's 3 question marks. I assume it's 3 questions.
I see. So 6 in each
See,
one.
get it? You see? It's so funny. All right, so now we have to find neutrons in the same ones,
Am I the only one who
which
needs to
is
document
different.
everything, or-
Yeah, because one of you will present your
Okay,
tables. I mean, I gave you a packet, everybody a packet so you can work on it.
Okay, so I'm the
Okay.
official recorder.
The official.
You are the official recorder? Awesome. I'm just looking at my own notes then. So then, the neutrons for those same 3 elements.
6, 7, and 7.
Yes, that's
Yes,
what I
in
have.
that order.
Good job, guys. Thanks, cheerleader.
And then the electrons, which I am not certain, but I believe it's, no, I don't know where that number comes from. Is it, we literally have to count the dots?
We just count the dots?
It's a negative.
Oh, see, we have to count the dots because the other ones are labeled because they're in a clump.
Oh,
We're
I
not able
see.
to determine what is
Okay.
what, so we have to
Okay.
count them. So everyone want to pick one to count? And
I'll
we'll
take
bring
the
them-
last one.
12?
I'll take the middle one.
And I'll record them.
So I have 7 for the last.
So 6, 6, and 7. Okay.
All right, based on the answers to CTQ critical thinking questions 1 through 3. I can interpret that.
That was good decoding.
Thank you. What do all carbon atoms and ions, the other ones are ions, that makes sense, have in common? They all have in, what is the same on each of them would be,
The number of protons?
the protons is the only one that is the same,
Fantastic.
It's
right?
a really
Yes.
good group.
Yeah.
That's
It's
a
been
sentence for the
ages
cheerleader.
So, based on the model, what do
Well, I
all
guess I should
hydrogen
use other
atoms
words
and
for
ions
wording.
have in common? What model? Oh, this one, up here, hydrogen, the first row of boxes.
Right, based on.
What do hydrogen atoms and ions have in common?
They all have 1 proton?
Yeah, that's what it looks like to me. Maybe see something different?
No, good job, guys.
Okay. Then what is the significance of the atomic number Z above each atomic symbol in the periodic table? Z. Z? Where is it Z? Where do I find Z? What? Oh. Okay, wait. I don't know where the Z means, but I'm guessing if you look at the way it's built, well, I'm gonna make a prediction because I don't know for sure.
Okay.
That vertically each column, like the first column, 1. So hydrogen each had 1 proton. That they each have.
And then 2, 3, 4, 5, 6, 7, 8. It goes in sequential order for the amount.
Yes,
of
that will be increasing
atomic number
similarity
increases.
of protons. So the atomic number, which is above the letter in the periodic table thing. You see, look at the key on there. So the atomic number is above the two letter,
So
one
it's
two
going
letter
left to right because
symbol.
the topper is 1, 2.
But it's not 1, 2, and 3 though, right? Because lithium is 3.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
Gotcha. Yeah. Okay. And that would be protons. So the atomic number equals the number of protons. Does anybody think
No.
differently?
No, I don't know because I'm not following what you. Could
So-
you clarify this? Are you referring to these numbers above the?
No, I think we're on the periodic chart.
Okay.
On the first page.
Yeah, so the periodic table. So I think we're on this one now.
this
So atomic number here,
Okay.
there, and since H was 1, and then C was 6,
Because
and
the
we determined
periodic table that I had
that
for this
represented the
one,
protons
Okay.
as
it
well.
says
And
Z.
we can
Oh, guys,
potentially assume that the atomic number
it's
matches the
just
number
a
of
different
protons.
convention
Okay.
for
So
like
they're
the
just
periodic
saying
table.
Sounds-
Z as in like
That that makes sense.
so like X, like
Got it. It's a variable.
actually
Abe
look for
at.
the Z.
Right.
Yeah.
So
I know
then-
it's like I get it. What they're it's the same thing. It's just not labeled the same.
So then,
Yeah.
I think that that the significance would be that the atomic number matches the number of protons in the atom and ions. Does anybody think differently?
Wait, I'm sorry. Say that again.
That the atomic number
Matches what?
the number of protons, because one was we said that C6, those numbers were the number of protons.
We're clarifying.
Predict further that the atomic number represents the number of protons.
So atomic number matches protons.
Yes.
Who's the spokesperson?
Me.
Okay, so what's going on, Danielle?
So we found that the significance of the atomic number in the periodic table is that it matches the number of protons in the nucleus.
In the nucleus, okay.
Want to keep going into another question?
Okay, based on your answers to
Okay, based on your, to the number 6, what do all nickel atoms have in common? Nickel Ni, which is, let me know if you find the number. Oh, 28.
28.
Okay.
So then, what do they have in common? Well, then, if we're assuming that 28 is the number of protons, we have to assume that it's 28 protons for all of the nickel atoms.
Okay.
Does that make sense to you?
That makes perfect sense.
So
Yeah.
I'm sorry, say it again. So there's just 28.
28 protons.
Protons.
Because it's atomic number 28.
Okay.
But then all of the nickel atoms would have the same number of protons. Right.
Which is what makes them all nickel. And the different neutrons and electrons, what makes them various ions of the element. I remember high school chemistry!
I actually really liked chemistry.
Okay, so
Only
then
thing I got.
in terms of the numbers of protons, neutrons, and electrons, why does the notation 13C minus have a negative sign in the upper right-hand corner? So this probably means back to the first chart with the big squares.
Yeah.
Right.
The one on the far right?
Right. So C minus. Okay, wait.
It has more electrons.
But so hold on, but look, the carbon itself, the plain one, normally the atom, not the ion, is 12C, and it has 6 protons and 6 neutrons. And then the next one has 6 protons, 7 neutrons, and it's 13, right? And then 13C minus was also 13 total protons and neutrons, but then where does the negative come in? Ooh,
It has one more electron.
that's its extra electron.
Yeah.
Alright, so then what feature distinguishes a neutral atom from an ion? So, well, if we look at